Hi everyone, welcome to this video on lesson 11 of the Earth and Climate Scheme of Work. So this lesson is on uses of fossil fuels. It's called that really, it possibly should be called combustion of fossil fuels because that's really what the lesson is about. And this is about, the main focus of this exposition is about how a car engine works. And I think this is really helpful in terms of what we're going to do is show the process by which we go from hydrocarbons, as in fossil fuels, which we go from that process to carbon dioxide being ejected from the car, and that's going to fit into our carbon cycle. So the first thing that I would do in this lesson is just to show students again this big picture. What's the whole story that we're trying to tell here? Well, the whole story is what we've looked in the previous two lessons, well, certainly in the first lesson, how carbon is stored underground by decomposition of dead animals. We looked at how we can separate that mixture of stuff that we have in there so that it can be used in this stuff. And what we're going to look at today is how is that used? What exactly is the process by which cars, aeroplanes, industry, trains, whatever, combust or burn the fossil fuels in order to release CO2 into the atmosphere. So that's what we're going to look at in this lesson. And it's not just useful in terms of students understanding climate change and the carbon cycle and so on, but I mean, it's also just really good general knowledge. A, so that they're well informed about climate change and energy policies and so on, and B, all of them will drive in a car at some point, and it's kind of we kind of owe it to them to understand what's actually going on in the engine. So the way I've laid this out, this is my piston, and I'm going to show this kind of 4-stroke cycle of a very simple engine. This is one of those classic lessons where it definitely needs to be a multimedia experience. They need to see this kind of moving as well as you kind of breaking it down. And I think it's quite hard to draw kind of crankshafts, and I can't remember half of the stuff that it's called, but the way the piston causes the crankshaft to rotate, which causes the axles and the wheels to rotate. I mean, it's quite complicated. What we're going to look at is really what's going on in terms of that chemical reaction between the fuel and the oxygen and how that relates to the pistons going up and down. So we're going to keep it quite simple, but you do want to give them a bigger picture and show them videos. If you've got any way of demoing it in class, do that as well. But yeah. So what I'm going to start by doing is saying the first thing that happens is we put this mix, and by the way, I've left a gap here because I'm going to do some zoom in diagrams, so I would recommend that you do that, and if you're getting students to draw with you, tell them to leave a gap of a few lines up there. But we put this mixture of fuel plus oxygen goes in, and then the first thing to notice is in terms of this 4-stroke cycle, what that does is causes the piston, which I'm going to draw like this, the piston to be pushed downwards. So if I draw my piston like this, by forcing the fuel and oxygen in, that forces the piston downwards. So then what we've got is this mix of fuel and oxygen in here. We don't need to worry too much about states and stuff at this case, and I mean, I can't remember how the modern injection engines work, but obviously the carburetors used to turn that fuel into a very fine mist to get as much combustion as possible. Whether that's, I mean, it's tiny droplets of liquid. We don't want to get too worried about that, but anyway, the point is you're getting fuel and oxygen in. And then there's this next cycle where the piston comes back the opposite way. So I might draw it a bit up here, just to show that it's on the way back up here. So if I draw my piston coming up like that, and again, this is where you're going to need a video because that is sort of, I would guess, I need to look this up possibly actually, but I would guess by the momentum of the crankshaft moving round, that pushes the piston back up. So you get this pushing back up, and therefore you get a compression of what's going on here. So I might add some labels here. This is what we call the intake. So the fuel and oxygen come in. And this is what we call compression. So it's a good opportunity to revisit that word. That comes up in lots of different contexts in science. The idea that it's getting squashed. Now, whether you want to do this or not is kind of up to you, whether you want to revisit Year 7 Particles and Energy, which they'll come back to in the Particle Model of Matter unit in physics. But this idea that if you squash something, if you decrease the volume, then you increase the pressure, and that's probably going to have an increase in temperature as well. And essentially, this kind of looks ahead a little bit to rates of reaction and stuff like that. But if you increase the pressure, then you're much more likely to get a chemical reaction because of the successful collisions. And that's what we're going to look at in the next part. So when this is really squashed, so I might draw it up here, when this is really squashed, that's where you get this spark. So I'm going to do that in red. That's where you get the chemical reaction starts to happen, and that pushes the piston back down again. That pushes the piston back down again. So this is called the power phase. So this is the power, because that's where the chemical reaction is happening. Now this is where I'm going to start zooming in, and again, it depends how much detail you want to go into. If you've got a really high priority in class and you think they're actually ready to look at this idea of particles being close together and more successful collisions, you could kind of bring that into your exposition. I'm just going to keep it quite simple and say, well, okay, if I look at what's in here, what was I introducing into here? Well, I was introducing two main sets of particles. So I'm just going to keep this really simple right now. This is not going to be a kind of what a chemist would think of as a really good diagram. And I'm just going to say you've got fuel. Now again, you could talk about, you know, if you wanted, depending on the group, you could talk about a gasoline engine and think about, well, that would be octane. So that's, now this is testing me, C88H18, whatever it is. I'm just going to put this as fuel particles. So because this is year 8, I don't want to go into loads of detail. I just want them to get the basic picture. Having said that, it might make it easier actually to talk about this as hydrocarbons, because what we're going to see later on here is we want to show them that through this chemical reaction, carbon dioxide and water vapor are produced. So I'll leave that up to you, but I'm just going to keep it really simple and say, well, you've got fuel particles and you've got oxygen particles. Although now I think about it, calling them F, that's probably a bad idea because they're going to get that confused with fluorine. So maybe I'm just going to shade those. So I'm going to shade these particles to show that they're fuel particles. And again, what I want to stress, and this goes back to what we've looked at in the previous couple of lessons on the formation of fossil fuels, these are hydrocarbons. These are made up of carbon and hydrogen. So what I can do in the next diagram, as this is getting squashed, is zoom in to show this kind of squashing process. So I might even just exaggerate this a bit and draw a smaller box and say, well, these 6 particles now have got squashed and they're all quite a lot closer together because of this process. So I'll do the fuel particles. I'm just going to do those in black, and then I'll do my oxygen particles. And again, I'm not doing it as O2, I'm just leaving them as O because I'm keeping it really, really simple for the time being. Again, if you want to give an even more accurate count, that's absolutely fine. In this diagram, what's happening here when I've got the spark, I'm just going to zoom in slightly to the side of that. So this is where it's super squashed, although I'm going to do it a bit bigger because what I want to show happening here is that these fuel particles, now I've done that in black, but anyway, these fuel particles are actually combining with those oxygen particles. Again, this is really, really simple. I'm not going into the chemistry because we're not going to do the kind of electron proper chemistry until we get later on, get to year 9. But I want to show that they're combining, and then I'm going to show that what we end up with is some different particles. So I might do 3 lots of these joining together. It is a bit squashed, but hopefully this is clear. So I might put an O there and an O there, shade that in black, shade that in black. So these particles now combine like this. There's some sort of reaction, and this is building on the kind of diagrams that we drew in chapter 9, or in section 9 on conservation of mass and reactivity. And what I end up with then you can show students that the products of this reaction are always the same. And this is the really important point that you want to stress. And I know now this is going to be really hard for me to draw. It's going to be a bit of a squeeze. But anyway, what I'm going to draw is that you always end up with CO2 and H2O. Now you don't just end up with one. This is not really representing conservation of mass. But what you end up with, instead of your fuel and oxygen particles, you end up with carbon dioxide and water vapor, or water particles, or molecules, I should say. And that's what I really want to stress here, because then we can come to the final phase. If I just move this down a bit, we come to the final phase, which is this has been squashed down, so the pressure of this has pushed this down, and that's where a video, something a bit more dynamic, is helpful. But what then happens is, again, the kind of momentum of the crankshaft pushes this lot back up, and these, I might just shade this to show that it's something a bit different, but the products of this reaction then get forced out. And what we want to emphasize is this is CO2 plus H2O coming out, and this is what's called the exhaust phase. And what you want to emphasize, therefore, is that because this chemical reaction produces carbon dioxide, this is why out of the exhaust pipe, it's carbon dioxide being released. And again, you might want to then come back to your diagram. You may even want to, possibly actually it would have been a good idea to start with a picture of a car first and then zoom in on what's going on before going straight into this very abstract picture of the engine. But back to concrete, well, we put fuel and oxygen from the air in. So what's coming out of the exhaust pipe? Well, this is CO2 plus water vapor H2O. So again, somehow relating it back to that concrete, that actual object that they see all around them on the road, cars driving around, or buses, or trains, or whatever, aeroplanes, and so on. But the point is that the key idea that we need to stress in this lesson is that when you burn fossil fuels, the products that you get are typically, amongst other things, as we'll see next lesson, but amongst other things, the main products are carbon dioxide and water vapor. And hopefully you can see now, by then coming back to the big picture, as we keep doing every single lesson, we're really starting to build this story, and they're starting to see how all of these different ideas link together into this really real problem that we've got, which is global warming and the greenhouse effect and climate change. So in the next lesson, we'll look at some of the impurities that get into fuels, and then some of the problems that causes in terms of atmospheric pollutants.